The Middle East is undergoing a rapid militarization of artificial intelligence, shifting the baseline of regional warfare to algorithmic speed. We're observing a transition away from standard software patches and incremental field upgrades. The architecture of military power is changing. The current strategic landscape is defined by two primary poles: capital-intensive predictive artificial intelligence anchored in Jerusalem, and decentralized asymmetric algorithmic warfare radiating from Tehran. An algorithmic command by one node instantly triggers an automated, networked response from the rival. The speed of this mechanical exchange forces non-aligned regional powers, like Turkey, to overhaul their own national defense strategies to survive the crossfire. To accurately model the next major conflict, we must analyze the specific algorithms and hardware supply chains that now govern state behavior. Israel maintains its regional dominance through a military doctrine built heavily around capital-intensive, predictive artificial intelligence to maintain a qualitative edge. Their defense infrastructure relies on integrated C4 ISR systems, networks of sensors, communications, and intelligence hardware that constantly map the physical battlefield, identifying and tracking moving targets in real time. By passing this raw telemetry through predictive algorithms, the system automatically calculates optimal interception trajectories, removing the biological bottleneck of human deliberation. We see this applied physically in layered air defense networks like David's Sling and the Iron Dome, where incoming threats are intercepted by automated hardware. This illustrates the apex of this doctrine, an AI system known as Hafsora. Vast quantities of raw intelligence, satellite imagery, audio, and field reports pour directly into the system. It algorithmically filters this volume, instantly outputting precise, actionable strike coordinates across urban grids. The primary limitation in warfare has historically been the time required to discover a target. Systems like Hafsora shift that limitation entirely to the time required for a human operator to authorize a strike. Confronted with an automated targeting monopoly, rival states cannot compete using conventional tactics. They are forced to engineer radically different technological methods to survive. This introduces an immediate mechanical problem. How does a heavily sanctioned state compete against a multi-billion-dollar artificial intelligence monopoly? The solution involves asymmetric scaling, driven by the rapid democratization of off-the-shelf commercial technology. Iran has engineered its military strategy around autonomous drone swarms, deploying massive volumes of physical hardware designed to exhaust and overwhelm air defenses. The engineering hurdle for these swarms is navigation. Without access to high-end Western silicon or reliable global positioning networks, the drones require an alternative method to reach their targets. This diagram reveals the workaround: inertial navigation systems. By isolating a basic gyroscope, accelerometer, and commercial microprocessor, engineers bypass satellites. The components process movement data, continuously calculating the drone's trajectory from its launch point, making the system immune to GPS jamming. The global commercial sector, heavily spurred by developments in automated electric vehicle manufacturing, has driven the cost of these basic microprocessors to near zero. Integrating $200 worth of commercial consumer parts with 200-year-old physical mathematics yields highly accurate, self-contained ballistic targeting. The convergence of cheap commercial electronics and basic physics bypasses traditional technological embargoes entirely. It allows any state actor to achieve precision strike capabilities on a massive scale. To map the geopolitical fallout of this rivalry, we turn to the international relations theory of structural realism. Realism operates on a core axiom: the international system is anarchic. Without a central governing authority, states must rely purely on self-help strategies to ensure their own survival. This flowchart illustrates the security dilemma. It is a mechanical feedback loop where an increase in Israel's automated defensive capabilities directly triggers a necessary increase in Iran's swarm-based offensive capabilities. Every action taken to secure borders decreases the relative security of neighbors. Turkey sits directly at the geographical center of this accelerating technological arms race, caught between two rapidly automating military powers. This structural insecurity required an immediate strategic response from Ankara, the development of a proprietary air defense network known as the Steel Dome. The steel dome is engineered as a multi-layered, algorithmically integrated radar and interception mesh, specifically designed to detect and neutralize inbound autonomous UAV incursions. Simultaneously, Turkey is scaling its own fleet of advanced AI-enabled unmanned aerial vehicles, ensuring it maintains a credible physical deterrent in the region. Thus, Ankara's rapid technological modernization is a mathematical requirement for maintaining sovereignty in an environment of automated threats. Artificial intelligence is operating simultaneously as a localized force multiplier for individual states and a massive regional destabilizer. Because commercial technology is universally accessible, the era of monopolized precision targeting has ended. This diagram tracks artificial intelligence across state actors, compressing the timeline of military engagements from human-scale minutes down to algorithm-scale milliseconds. This risks unhuman-in-the-loop escalation, where opposing algorithms detect each other and enter an accelerating cycle of countermeasures. There are currently no regional regulatory frameworks or automated crisis management systems designed to govern or interrupt these autonomous weapons. The ultimate risk is competing targeting algorithms locking onto each other, sparking kinetic conflicts entirely without human initiation. In the new architecture of automated warfare, conflicts now possess the capacity to escalate faster than human diplomacy can physically intercept.